Hey everybody, we're back. So we're going to continue with this 2015 Mcas here. We're going to pick up where we left off. So this is number 8. We're going to see how far we get. And again, the idea of this is to help you guys look at some of the previous content. This is a 6-year-old Mcas, so I mean, it's definitely different from what you're seeing now. The format's different, but I still think there's value in seeing this. The PDF is found in the video description. If you want to download this, try it first, and then watch these videos. I think it makes a lot more sense to do it on your own first, and then see how you did. I wouldn't watch this yet until you've actually already tried these. All right, so let's get right into it. So number 8, J and Kalani graphed lines on a coordinate plane. J's line is represented by the equation below. We have a linear equation here, y equals 2x minus 5. Kalani's line is parallel to J's line, which of the following could be an equation of Kalani's line. Okay, so again, one of the tips I like to do is if it's a written format like this, I like to write on the test a lot. It's one of the, and then when you take the digital test in May, you can use, well, at our school we use dry erase markers on the actual Chromebooks, which I think make it easier. I'm actually going to pause this because my next door neighbor is being loud. I'm going to shut these doors. Hold on a second. Okay, there we go. So, all right, so it's a linear equation. Kalani's line is parallel to J's line. This is J's line. We're looking for the equation that's Kalani's line, and we know it's parallel to it. So if they're parallel, that tells us about the rate of change or the slope. The rate of change would have to be the same. So we're looking for a line that has the same rate of change as this. We're looking for m equals 2. Easy enough. The only problem is all these equations are in standard form. We want to put them in slope-intercept form. So we're going to get y by itself. So let's go ahead and do that. So we're going to take this equation and get y by itself. So 2x plus y equals negative 5. Let's get y by itself. So we're going to subtract 2x from both sides. And you're going to get y equals negative 2x minus 5. Unfortunately, that is not the same rate of change, so that's out. Let's try this one, b. So I'll try to write this a little bigger so it's easier to see. Negative 2x plus y equals 5. We're going to add 2x to both sides. And we're going to get not a lot of room here. We're going to get y equals 2x plus 5. So here we go. Look, we know it's the same rate of change. This has to be the answer. If you do the rest of these, you're actually going to end up with, let's see, this is going to be negative 2, and this is going to be, sorry, not negative 2, it's going to be negative 1/2, so it's not even going to be, yeah, so it has to be b. If you go ahead and do the rest of these to get y by itself, you're going to see it doesn't work, so it has to be b. We're going to save ourselves some trouble, and there's just not a lot of room to do this. So, number 9, the first 2,450 people to attend a baseball game received a free hat. A total of 19,544 people attended the game. Which of the following is closest to the fraction of people attending the game who received a free hat? So it's free hat on top and attended on the bottom. Okay, so notice they gave us the keywords closest to, which means we're going to estimate. Now, the less you move these numbers, the more accurate your answer is going to be. So let's go ahead and look at this. So we have 1/20th, okay, which is roughly 5%, 1/8, 1/5, and 1/4. I don't know 1/8 off the top of my head percentage-wise. This is 5%. This is going to be 20%, and this is going to be 25%. This would be less than, more than 10%, but less than 20%. Like 15, I'm guessing. What's 15 times 8? No, it's less than that. We'll figure it out. Let's do it right now. I'm just curious. Do you have to do this to solve this problem? No, we don't, but I'm just actually really curious. So we're going to bring 1 here. Let's see more room here. 1 times 8 is 8. And there's definitely a more efficient way to do this, but I think it's, I don't know. I find weird things fun. We're going to go in here 12, 16, 4. It's 12.5%. Okay, so roughly 12.5%. Do we need to know that? No, I don't know why. I just wanted to do that. So, all right, let's figure this out. So, let's round this. We're going to make this 20,000. Okay. We're going to make that 2,500. Oops, too many zeros. And we're going to simplify this. So that goes away. That goes away. And we have 25 over 200. If we simplify that, divide them both by 25, we should get 1/4. It's not 1/4, sorry, 1/8. What am I thinking? Still waking up. 1/8. So I think it's actually going to be that B. That's what it looks like to me. Now, if you had a calculator, you could very easily do this. You could do this divided by that as a fraction, simplify it. But I think this is probably the easiest way to do this. So you estimate this to 2,500, estimate that to 20,000, and then you just simplify it. Okay. This does require you to know how to simplify. Some people struggle with that, but if you can do that, this shouldn't be a problem. Okay, so this is another order of operations problem. Which of the following is equivalent to this? So, no, it's not order of I guess it is. It looks like they didn't finish the whole thing, but they did a step. That's what it looks like to me. So let's go ahead and write our acronym here. So parentheses, exponents, multiplication, division, a single step from left to right, addition, subtraction, single step from left to right. Don't write it like this. I'm sure my students have already heard me say this. Don't write it like that. You know why not to write like that? Because this makes it look like you always multiply before you divide. You don't. Multiplication, division is a single step from left to right, as is addition, subtraction. I see people writing like this, and they're always making the same mistake. They always multiply before they divide, like I would see people doing here. So there's no parentheses here, but there are exponents. So the first thing we should do is 5 squared, which is going to be 25. So we're going to get 4 plus 36 divided by 2 times 25 minus 3. So do any of these have this? We have, it looks like they did 2 steps here, because like 4 plus 18, yeah, something happened here. 4 plus 36 divided by 20, yeah, something happened. So we're going to do another step here. So, and this is actually what I'm talking about. People would actually multiply these before they divide, which is wrong. So we have no parentheses, we have no exponents. We have multiplication division as left to right, so we're going to do this first. 36 divided by 2 is going to be 18. So 4 plus 18 times 25 minus 3, which I think is the first one here. 4 plus 18 times 2, yeah. So you can see here, if people that aren't familiar with how you actually do order of operations, they would make a mistake here. A lot of people would multiply first because they write it this way and they see the M before the D, so don't make that mistake. All right, let's try number 11. Scatter plot below shows the relationship between the total monthly sales in millions of dollars at a retail store and the monthly commissions in dollars earned by one salesperson. Okay, based on the line of it's down here. Based on the line of fit for the scatter plot, which of the following is closest to the monthly commission that the salesperson could expect to make when the total monthly sales at retail is 0.8 million? Okay, so we're looking. Okay, so here's the deal. We have a scatter plot here. We're trying to find out what would the monthly sales be based upon the line of fit what would the commission be if the monthly sales total was 0.8 million or 0.8 million? Okay. So we don't have a dot here, but we do have enough points to make a line of fit. So we're going to do that. So I've got a ruler here. Now, one mistake a lot of people always make is they think the line of fit has to start at the origin. It does not. And in this case, you really don't want to do that. Here you want the line that best represents the data. So I would say it's about here, roughly. Let's see how that looks. Yeah, that's okay. It could be a little lower, but that's fine. So that's going to be our line of fit. And if we look here, somewhere in that area, we're looking for something between 4,000 and 5,000. Right? This is the area that it'd be marking. That's going to be, again, this is loose. It doesn't have to be exact. And remember how I said, I think actually it'd be better if I did it this way. It's kind of hard to do this. Something more like that. Either one of those would be ideal. I think, now I'm looking at it, I think it's one of maybe between the two. But anyway, it's good enough. It gets you in the general area. And you can see here that, well, it's certainly not 1,500. That's all the way down here. That's out. 2,500, that's all the way down here. That's out. 4,500, yeah, that's just right. Okay, I think that's going to be it. And then 6,500 is far too high because the area in which it's crossing is right between 4,000 and 5,000. So your line doesn't have to be perfect, but it definitely can't start down here. If you did that, it's not going to be, it shouldn't start down there. Anyway, so we're looking for C on that one. Let me zoom out a little more. Number 12, which of the following is equivalent to the expression below? Again, this one's pretty easy. You're not going to see one like this on the new Mcas, unfortunately. I wish it was. So multiplicative inverse of 12 is 1 over 12. What's 12 times 1/12? That's just going to be the number 1. So that's B. Because 12 times 1 is 1, 12 over 12, 12 times 1 is 12, 12 over 12 is a 1. Okay. Let's get a few more of these done here. So Leah took a 5-day car trip. The table below shows the number of miles she drove in each day of the trip. So day 1, And this is definitely not cumulative. This is just how many miles each day. So day 1 and so forth and so on. Of the total number of miles that Leah drove on her trip, which of the following is closest to the percentage she drove on day 1? Okay, so we're looking for the percentage of what this is in compared to the overall. So to do that, we'd have day 1 over the total. And then we would multiply that by 100. And that would give us the percentage. So we know day 1 is 297. And we have to add these all up. Now it's asking for the closest to. I'm not going to round any of these. We're just going to add these up. So I'm going to write these down. So 297, 179, 203, 131, and 192. So we're going to add these all up. Make sure I didn't screw that up. I didn't. Okay, 7 plus 9 is 16. Plus 3 is 19. Plus 1 is 20, 22. Carry the 2. 11, 18, 21, 30. Carry the 3, 5, 6, 8, 10. So, yeah. So now we can estimate. So this is the total miles driven. This is the miles driven on the first day. I'm going to round that to 300. I'm going to round this to 1,000. Cross out the zeros. 3 over 10 is going to be 0.3, and then times 100 is going to be 30%. It's roughly 30%, which is going to be our D option here. Okay, number 14. Which of the following is equivalent to the expression below? So we have two binomials, and they give us a polynomial. We're just going to distribute these. So distribution property. So x times x is x squared. X times 4 is 4x. Distribute the 3. 3 times x is 3x. And 3 times 4 is 12. Combine these, we're going to get 12x. So we have x squared plus 12x plus 12. Why do you get 12? It's 7x. Jeez, Brian. My goodness. I was looking at that saying, why the heck is... See what I did there, guys? I multiplied 4 and 3. That's what you do when you try to go too fast, too quickly. So that's going to be letter D. All right. Okay. So do we have time to do one more? I think we do. Let's try to get one more done, or two more done at least. Yeah, we'll try that. We'll try to get before the short answer here. So the diagram below shows a right triangle and some of its measurements. So here's a little nice thing to know. This is 90. This is 30. That means this is 60 degrees. So this is a 30, 60, 90, which is a special right triangle. What is the height in meters of the triangle? So let's go ahead and look at our formula sheet, which is right here. If you don't remember these, that's okay. It's right here. So 30 degrees, the side opposite of 30 is going to be our, in this case, I hate it how they use y here. I don't know why they do that. Let's call this h, I guess. This would be 2h, and this would be h radical 3, according to our formula right here, which is available. Okay. So we're looking for h. So we know this is 2h, so 18 equals 2h, which is, okay, h is going to be equal to 9. All right, divide both sides by 2. H is equal to 9. And that's it, 9 meters. Okay, and then number 16, the box whisker plot here. A doctor recorded the resting heart rate in beats per minute of each of her patients. The distribution of the heart rate to this group of patients is shown in the box whisker. Okay. Based on the box whisker plot, what was the median resting rate in beats per minute? So median is represented by the middle tick dash within the box. So this is actually our median, also known as our Q2. So this is 80. So the median is 80 beats per minute. And that's it. Okay. And then we're going to stop there because we have a short answer. We'll do that later. Let's go ahead and check our answers. So let me go back here. Oops. So we'll go back all the way to number 8. We'll get our answer key, because remember, guys, the answer key is available in the PDF at the end. So number 8, we got B, which is the correct answer. Number 9, we got B, correct answer. Number 10, we got A, correct answer. Oh, that's good. Number 11, we got C. Get that one right. Number 12, we got B. Awesome. So far, so good. Number 13, we got D. D's there. And then the last one, 14, we got D. Okay, so we got those all right. That's awesome. Cool. All right, guys, so hopefully that was helpful. We will continue this probably tomorrow if I have time, and we'll try to get. Oh, hold on, 15 and 16. Oh, I forgot. 15 and 16. See how we did. So 15. Does it have the answer? Oh yeah, 9 meters. Look at that. Boom. And then 80 beats per minute. Got it. So nice. We got that. So tomorrow, if we have time, I'll try to do another video on the short answer for number 17, and we should be able to finish this 2015 MCAS probably definitely by the end of next week. All right. Thanks for watching, guys.